The runway disappears twice a day, not because of fog or flooding, but because the tide comes in and swallows it completely. And yet, scheduled commercial flights have been landing here for decades. Barra Airport sits on the Isle of Barra, off the northwestern coast of Scotland. The entire runway is a stretch of tidal beach called Tràigh Mhòr, a Gaelic name that simply means the big strand. At low tide, the flat expanse of compacted shell sand measures roughly 1.5 miles in length and wide enough to accommodate 3 parallel landing strips. At high tide, all of it vanishes beneath the Atlantic. That single physical fact creates a problem that no amount of conventional airport engineering can solve. You cannot pave a beach. You cannot anchor a runway to sand that the ocean reclaims on a fixed schedule every single day. And you cannot operate a scheduled airline service without some predictable surface for aircraft to touch down on. The question Barra Airport has been answering for most of a century is not how to build a runway here, but whether the beach itself can serve as one, and what has to be true about every single flight for that to work. The Isle of Barra is a small island in the Outer Hebrides, home to roughly 1,000 people. Before air service arrived, reaching the mainland meant a long sea crossing subject to the same Atlantic weather that makes this stretch of coastline one of the roughest in the British Isles. The community needed a reliable connection to the outside world, and the beach at Tràigh Mhòr was the only flat ground on the island large enough to be useful. Regular scheduled flights to Barra began in 1936, operated initially by what was then a pioneering era of small regional air services in Britain. From the start, the operation was built entirely around the tidal cycle. There was no fixed infrastructure on the sand itself, no tarmac, no lighting embedded in the surface, no painted centerline. The beach was the runway, and it would remain the beach. What made this workable, rather than merely adventurous, was the particular character of Tràigh Mhòr's sand. The beach is composed largely of compacted shell sand, a dense, load-bearing material that, when the tide has fully receded, provides a surprisingly firm and consistent surface. It drains quickly, it compresses under weight without the kind of soft give that would trap a landing wheel, and it is wide enough that pilots have meaningful lateral margin. The beach does the structural work that poured concrete does everywhere else. It just does it on a schedule set by the moon. The constraint this creates is absolute. Every single flight schedule at Barra Airport is built around tidetables. Loganair, the Scottish regional carrier that operates the route today, publishes timetables that shift week by week, month by month, tracking the rhythm of the tides. There are days when no flights operate at all because low tide falls entirely outside usable daylight hours. There are periods when morning flights are possible, but afternoon returns are not. The passengers adapt to the airport's calendar, rather than the other way around. For the pilots, the approach to Barra demands a specific category of skill. The beach has no instrument landing system. Approaches are made visually, and pilots must assess the surface condition on every arrival. After periods of heavy rain or rough seas, the sand can hold pools of standing water or patches of softer material that were not present on the previous flight. The surface is inspected before each landing, and ground staff check the beach daily when flights are scheduled. The airport's entire operating philosophy rests on continuous, direct observation rather than permanent infrastructure. There is also the question of what the tides leave behind. Seaweed, driftwood, and debris arrive with every high water. Before flights, ground crew walk the beach and clear the surface. Cockle and razor shells, the very material that makes the sand load-bearing, are present in abundance, but larger debris must be removed. The maintenance interval between flights is, in practical terms, measured in tidal cycles rather than months or years. This operating model has a cost that goes beyond the unusual. The airport cannot be used at night, for the same reason it cannot be used at high tide. Visual surface assessment is the fundamental safety check, and it requires daylight. Aircraft types are limited to those whose landing gear and weight are compatible with the surface. Heavier jets are simply not an option. The route has historically been served by twin-engine turboprop aircraft, the de Havilland Twin Otter, and later, the Britten-Norman Islander among them, light enough to land on compacted sand without breaking through, and capable enough to handle the Atlantic crosswinds that funnel across the beach with nothing to stop them. The crosswind problem deserves particular attention. Tràigh Mhòr is oriented roughly north to south, which means wind approaching from the west, the dominant direction on this coast, strikes the landing surface at an angle. Pilots landing at Barra regularly contend with crosswind components that would challenge operations at airports with full instrument approaches and long, sheltered runways. The combination of a visual approach, a tidal surface, and a persistent crosswind makes Barra one of the most technically demanding scheduled service airports in the United Kingdom by any practical measure. There have been arguments over the years for replacing the beach arrangement with a conventional hard runway on firmer ground elsewhere on the island. The counter-argument has always been the same. There is no other flat ground large enough, and the cost of engineering a permanent runway on a small Atlantic island, including access roads, drainage, structural foundations in difficult terrain, would be enormous relative to the traffic volume the route supports. The beach, for all its inconveniences, is free infrastructure provided by geology and tide. It is maintained by the ocean itself between uses. That trade-off has shaped the airport's present reality. Barra Airport is a licensed commercial aerodrome, regulated by the Civil Aviation Authority. It operates under specific conditions tied to weather, daylight, and tide. Loganair's service connecting Barra to Glasgow is the lifeline route that the community depends on for medical transport, freight delivery, and basic access. The beach is not a novelty or a compromise accepted reluctantly. It is the only viable answer that the geography of the island has ever produced. What Barra Airport demonstrates is not that beaches can substitute for conventional runways in general. They cannot. The specific conditions at Tràigh Mhòr, the composition of the sand, the geometry of the beach, the tidal range that exposes a usable surface for predictable windows each day, are essentially unrepeatable. What it demonstrates instead is that infrastructure does not always require construction. Sometimes it requires reading what the environment provides, building an entire operating system around the constraints that cannot be changed, and accepting that a schedule defined by the moon is not a flaw in the design. It is the design. Flights still land on the beach at Barra today. The tide still covers the runway twice every 24 hours, and the people of the island still check the tide tables before they book a flight home. The next time you see an airport defined by what it lacks, no tarmac, no fixed lighting, no instrument approach, the real question is not what was forgotten in the construction. It is whether the engineers understood that some problems cannot be solved by building, only by watching. The beach does not wait for the schedule. The schedule waits for the beach. And that difference is what makes the entire operation possible. Visual reconstructions are illustrative. Facts and interpretations are based on the sources listed in the description.